The topic of today's video is printing middle element in the linked list using Python. We'll be doing the hare and tortoise method for printing the middle element of the linked list. So now we move to the hare and tortoise method. In hare and tortoise method, here we take uh, in this method we will have two pointers. First one is a slow pointer and second one is a fast pointer. That's why we named it as hare and tortoise method. As the when the tortoise move one step, and that the hare will move more than one step. Started from the head element of the linked list. So until the tortoise move one step, in that the hare will move more than one steps. So this is how we do it for finding our middle element. So in that initially, so what we have initially, so we have this head and we have 1 2 3 4 5 elements. So out of that we want to find the middle element. Okay, so what will the first step? Firstly, we will define the slow pointer and fast pointer. So they both start from the head only, and then we will start moving the both the pointers. So we'll define that the slow pointer will move one step, and in that fast pointer will move double of it. So if slow pointer is on 2, when the slow pointer is on 2, at that time the fast pointer will be on 3. The fast pointer will move 2 steps. That means it will be on 3. So when it will be on 3, then it will come to the 3, and then it will go to the 5. So it works like that. So in second step we have, yeah, so this was our the first steps. In second step we have, as I told you, that when the slow pointer is at 2, at that time the fast pointer is at 3. So here we have, and that in the step 3, we have when the slow pointer moves to the 3, at that time the fast pointer is at 5. So now what is the point of taking the slow and fast point, the hare and tortoise method? So now when the slow pointer, for example, we have 100 of the elements in the linked list. So in that 100 of the elements, when both are at 1, so when it moves one, slow pointer will go to the next element, the fast pointer will go to the next element. So in that, when the fast pointer is at 100, the slow pointer will be at the half of it. Okay, so if it has covered all the 100 elements, at that time slow pointer has covered only 50 elements. So that means when our fast pointer has reached to the last element of the linked list, at that time our slow pointer will be at the middle element. So with this method, it will be easy for us to find the middle element. We get the middle element, then we'll print the slow pointer. Where's the slow pointer? At the middle element. So in step 4, that means there's step 4, so it will keep on moving until the fast pointer will reach to the last element. So now we have fast pointer, the fast pointer next is equal to null. That means the next element. So in like linked list we have nodes. In that nodes we have a data, and then we have a next element that is addressed to the next node. So now if you see that if next is equal to null, that means there is no address to the next node. If there is no address, that means that element is the last element. So if that is null, so the will create a loop, the loop will break. So at that time, the slow pointer will be at the middle element, then we will print the data of the slow pointer. So this is how we get the middle element of the linked list. Okay, so now I have explained it through I have explained it thoroughly. Now we'll go to the coding part by using Python to understand it well. So now we have come to the coding part. So firstly, we'll be creating the linked list. So for that, firstly, we'll create a nodes. Firstly, we'll create a class node, and then in which we will be defining init method, self, and data. These are the attributes. Now in the node, we have basically two attributes. That is, first one is data, and the second one is next. Oh, sorry, wait. Data, and the second one is next, which will store the value of the which will store the address of the next element. So firstly it is set as none, and then our node class is created. Now we'll create the linked list class. we have created the linked list class. In that linked list class we have, wait, okay, then we have will be initializing it, which is cell. And then we have and in that linked list, the main the attribute which will we have is node head, so that is self dot head. And firstly we have set it as none. And now in that now we'll be defining a print. We'll be adding the elements in the linked list. So this is self dot self, sorry, comma, have a print. Then so now we'll have the new node is equal to, now we'll call the now we'll call the node function over here. Node is equal to data. And now if not self dot head, not self dot head, then self dot head is equal to new node. Like if initially it was empty, then it will take the new node which we have created as the head element. So it will be the first element of the linked list. Else, as what will it will print? It will firstly take a pointer that is equal to self dot head. Now we'll create self dot head, and now in that we'll be creating a loop, that means while current dot head, that means until we reach the last element. Then how we define this, sorry, current dot next, sorry, that means the last element will reach up to then current is equal to and next. And then we come out of the loop, we have current dot next is equal to new node. So now we have created the linked list class successfully, and now we have the node class. And then we'll be defining our main function, which is printing the middle node. So I'll be defining it. We'll have define print middle node. So we've defined this function. In that we have write linked list. So in that function, firstly we'll check. Okay, firstly for getting the middle node or anything, firstly we'll check if our linked list is empty or not. So if not link list dot head, that means if there is no head, that means if there is no beginning, that means there is no linked list over there. So if not linked dot head, then it will print that the linked list is empty. So and then it will return, it will stop the whole code over here. and and then we came out of the print if statement. Then we have, now we'll firstly define our so now we'll firstly define our slow pointer and the fast pointer. So what is our slow pointer? Tortoise. It is our slow pointer, that is equal to linked list dot head. So firstly, I have set it to the head. Now that means it will start from the head. So the value we gave here, it means that it is the initial value which we have given to it. So initially it is at head, and then we'll be creating the we'll have the fast pointer over here. Okay, so now we have created the fast pointer and the slow pointer. We have put it on the, we have set the initial value as head. Now we'll run the loop. So as we have seen it, then so now what we're gonna do is that now we have seen that now after initializing it, we have set it to the in the beginning. So now we'll move it. So now we'll run a loop that it will that if the slow pointer will move one step, the fast pointer will move double of it. So how we'll do it? That so now while here, here, and here dot next. That means that while we have the, yeah, that means that like we'll run a loop until we didn't reach to the last node. So tortoise is equal to tortoise dot next. Then tortoise will move to the one element, that is tortoise dot next, and here will move to here dot next dot next. That means here will move to the next pointer. So now, so this how we are defining it, that when until we reach to the last element, until we have a here and a here dot next. That means the until we have a data of the fast pointer, and we have a, like at the end we have that next element, that means address to the next element until we have it. That means we'll reach to the last element. Up to there, it will take the tortoise will take one step to the next, and here will take the double of it. So if the tortoises have moved 50, so if here has moved 100 steps, that means tortoise have moved only 50 steps. That means half of it. So now, after that, we'll print middle node value. So now we get the middle node value. So what is the middle node value? That is where is tortoise right now. So that means tortoise dot data. We'll get the data of the tortoise. So here we have this. So we have written the whole code. Now we'll take an example. Okay, we'll be defining our link list, that is equal to link list, and then we'll be adding the elements over here. That means link list dot uh, link list dot append. We have one over here. So we have added, start adding the elements. This two. Uh, so now I have created a linked list. Then I will print middle node is and link list. Now we're written it. So our code is complete. We have given example. So in that, and that I have taken 1, 2, 3, 4, 5. So what will be my middle element? I know 3. So my output will also supposed to be 3. So we'll run it. And yeah, here we'll get the middle node is 3. So this was the hare and tortoise method. Thank you so much.